While storing a large variety of datasets is one of the main goals of ML data, another important purpose is to support the construction of machine learning benchmarks and challenges. The underlying idea is to allow users to define machine learning tasks, which are well-defined machine learning problems utilizing the data on the site. Such a task not only specifies the specific learning problem to be solved, but also precisely defines the evaluation measure so that the performance of competing algorithms can be compared. Currently, ML data supports basic classification and regression tasks with a variety of different performance measures. In this demo, we'll use the banana classification task, which defines a classification problem for the data that we previously downloaded. So the task definition includes both unstructured fields that can be used to describe the input and output of the predictor, and a number of structured fields that describe the specifics. The task definition, that is, the definition of which variables should be predicted, and the specific split into training and test data is available for easy download, just as the original data. So let's download the splits in Octave format. Okay, let's switch to Octave and load the file. So here, input variables and output variables define the prediction task, while the indices train IDX and test IDX separate the available data vectors into the training set and the test set. So I'll go ahead and divide the data into training and test vectors, and then I'll plot the training data. To start with, I'll need to offset the indices by 1, since in Octave the indices start with 1, whereas in Python and on ML data the indices start with 0. Then I'll actually do the split into training and test. And then I'll plot the training set. So we're going to apply a very simple nearest neighbor classifier to predict the labels for the test data. I've written a simple function called KNN that takes as arguments the training vectors with their corresponding labels and the test vectors without the labels, and computes the predicted labels. To get some perspective to what the method's doing, let's plot the test set with the predicted labels. Finally, I'll save the predicted labels into a text file. So how well are we doing? Well, to be able to upload our results, we need to be logged into the mldata.org site, and for that obviously we need to be registered first. So let's start with registering. So we only need to add some quite basic information to set up the account. Our name, username, email address, and desired password. So once you've submitted the form, you'll get an email with a link to activate the account. And when you've activated the account, you can sign in using your username and password. So now let's go back to the banana task and upload our results. So the uploading of results is done on the rightmost tab called Results/Methods. There are no results yet on this task, so we're going to get to top the leaderboard, at least briefly. To be able to submit your result, you need to have at least a brief description of it for others to see. This you do by creating a method object. The only mandatory item is the name, but it may be useful to add some other information as well, such as a brief summary and other information on the method. Okay, then we submit the method. Alright, now we're ready to upload our results and see our accuracy. So our accuracy was almost 87%, quite a bit better than random guessing, but it's probably not hard to do better on this task.